Budget cuts to NOAA and the National Weather Service have produced questions throughout the duration of 2025 about the reliability of weather data. Would these cuts impact how accurate weather forecasting would be and how much you can actually trust the weather forecast that you're getting? We spent some time diving into some of the factors that determine how accurate weather models are, and we're going to talk in this video about how weather models are produced, what key data is being utilized to produce weather models and weather forecasts, and how changes in the budget cuts have potentially impacted the accuracy of forecasts, and ultimately, what can you do to better prepare if the reliability is a little bit lower with weather model data. To start out, we need to look at where it all begins, and that's with observations of the atmosphere. It's with weather balloons. Weather balloon data is critical to put into weather models that can produce complex and create complex calculations that ultimately give you the weather forecast that you consume on a daily basis. That free weather app on your phone is likely just taking in weather model data that has been produced and spitting it out to you. And so if our reliability in weather models has lowered, if they're not as accurate, then the forecast that you're getting in that free app on your phone every day is also not going to be as accurate. So it's really, really critical to understand this process. Starts out with weather balloons. Weather balloons are launched upwards through the atmosphere. They remain in the air for about 2 hours. They rise over 30,000 feet before they pop, and the instruments fall back to the surface. Throughout their ascent through the atmosphere, they're transmitting constant communications with key variables and values that the sensors have picked up and detected and observed, and then they're transmitted back to a station where they're then put to use for a number of different reasons. They're used for observational data sets where meteorologists can examine what conditions are throughout the atmosphere to get an idea of how to expect weather to evolve moving forward. They're also sent back into weather models, and all of the different variables, temperature, humidity, pressure, wind speed, wind direction, along with other more complex calculations that it produces from these variables, are put straight into weather models that then produce forecasts of the weather for all different parameters from anywhere from 18 hours all the way out to 15 or 16 days. And so this is the starting point of how weather forecasts are created. We have to start with the observations. We have to start with where the atmosphere is at. If our data is not accurate to start out, then our weather forecast models will likely not be as accurate the further out that they go. And so having a good starting point is a very important place to start when it comes to forecasting the weather and developing weather models that meteorologists use, that apps use, to help give you an accurate weather forecast. Another key thing that these balloons will provide are what we call atmospheric soundings. They give us a full picture of the atmosphere from the surface all the way up to 15, 16, 17 kilometers high in the atmosphere. They plot temperature and dew point and wind, and all of those variables combined are then put into equations and calculations to help determine how unstable is the atmosphere. Is there a lot of wind shear that could produce rotation and tornadoes? What is the overall picture and what could it mean? Could there be hail? Is there dry air in the middle part of the atmosphere? All of these different things meteorologists have been trained to look for using these soundings, using these weather balloons to help give you a weather forecast. And so the balloons are critical. They're just one piece. There's other aspects to this. Surface weather stations are also very, very important. Satellite data is critical. There's a number of different things that go into this, but weather balloons are a very important factor. And again, for the forecast, especially let's say beyond 6, 7, 8 plus hours, very important to have weather model data. The further out you go, the less likely you're going to be able to use current radar, current satellite, current station observations to give you a good idea of the weather forecast. We have to rely somewhat on weather forecast modeling. And there's a ton of different weather models. There's a complex set of equations that have been produced to go into these models to produce a wide variety of different solutions. If we ever completely solve those equations, then the forecast would always be right. These equations are not solvable, however, which is why there are hundreds of different weather models, and they all take this observational data that's been collected across the United States and across the globe to start creating weather forecasts. They have different equations, some different calculations, and so each one is a little bit different, but it's really critical to have a good starting point. Without a good starting point of variables from the surface to the atmosphere, from wind to temperature, pressure, humidity, moisture, precipitation, you name it, without a good starting point there, the less accurate the weather models will ultimately be. And so the weather balloon launches that are produced from NOAA and the National Weather Service are really, really critical to the accuracy of weather model forecasting. Now, what meteorologists have the capability of doing is looking at all of these different weather models and determining which one is initializing best with actual conditions, which one makes the most sense from a meteorology perspective. Does it actually follow the rules of the science? You'd be surprised how often weather models don't, because they're not perfect. Some weather models do great in some atmospheric conditions. They're more suited for situations near the coast or situations with storms or snow. Some models don't. And it's our job as meteorologists to determine when they're good and when they're not. But it certainly helps when they start off accurately, which, again, is aided by the weather balloon data. And so concern began to develop throughout this year that cuts to some of these weather balloon launch sites would affect the accuracy of the forecast. If we take a look here, here's all of the different weather balloon launch sites across the United States, including Alaska and Hawaii. Just this year, we have lost several different locations launching weather balloons. Specifically here, the red ones that you see, the red pins that you see, are sites that have stopped producing weather balloon launches. In fact, there's a decent gap here across parts of the Mountain West and the Plains where balloons are only launching once a day or not at all at this point. And so we do have a gap that, because of these cuts, we're starting to see. We don't have as much data collected in this portion of the country, which means that weather models for this portion of the country don't have quite as accurate of a starting point compared to where all of these other stations are. The question is, in the grand scheme of things, this is a relatively small area across the globe. Would it actually truly impact our weather model accuracy? We can look at that. We can look at the verifications. This is day 3, so 3 days out. Again, as I mentioned, weather models vary from 18 hours out to 384 hours out. This is day 3 sea level pressure and the verification of that. Typically, if your sea level pressure is off, then your wind will be off and your precipitation will be off, so it's a good parameter to start with. Looking here, since spring, we have seen a consistent downward trend. The big question is some of this variability related to normal summertime patterns and the very hot and humid summer that we've had that leads to a lot of pop-up activity? Or is this because of the weather balloon launches? While there's not a 100% foolproof way to know yet, we probably need more time to see how this evolves, the trend has been down, and there's no doubt about that. And certainly some of it could be attributed to the weather balloons. Again, it's not, 100% factual at this point. It's not 100% proven. We need more time and more data, but certainly looks like our weather model accuracy has dropped some since the balloon launches have stopped. If we take a look, they're still not bad, though. We went from verifications of 90 to 95% accuracy to about 85 to 90% accuracy and more variability. And so we as meteorologists need to recognize that there's probably going to be more volatility in the weather models, and with the changes with the balloon launches, that could continue. So what can we do to navigate this? Well, number one, we have access to a whole bunch of different weather models. Here's one right here. This is the AI European model. We've got high resolution data. We've got medium-term data. We've got all of these different parameters that we can look at for all of these different models. It is going to be more critical than ever that meteorologists are active and diligent with looking at all kinds of different weather model data. Meteorologists can recognize where model data is struggling, where they're inaccurate, what biases they have. If we're relying on one piece of model data alone, with the drop in the skill score, there's a much higher chance that your forecast will be less accurate than it was previously. So more than ever, the human factor is going to be so critical with weather forecasts. We can't just simply rely on what one particular weather model might say. One weather app may use specifically the GFS model, and all of the forecasts that you see on your app, your hour-by-hour forecast, your daily forecast, rain totals, whatever, it may just pull in this model. Well, if that particular model suddenly is less accurate, well, your forecast is going to be less accurate. Again, you have to have a human touch and a human analysis on the weather forecast to truly get an accurate forecast and a confidence in the forecast that you're receiving. So one of the things that we're doing to combat this is in our Clarity platform, number one, in the short term, we don't necessarily even need to rely on weather models. In the short term, several minutes to several hours out, we can use radar data, we can use station data, we can use other observation satellite data to help give us an idea of where storms are going to track, whether they're going to strengthen or weaken, what the impacts will be. We don't even need to rely on an hour-by-hour forecast from a weather model. We can send you more precise, direct, and detailed information. I think it's more critical than ever that people get these types of updates. We call them nowcasts. We give you an estimated time of arrival of storms, how much rain to expect, what the impacts could potentially be. Getting this kind of true personalized update from a real person, you just can't get it anywhere else. And again, if weather model data becomes less accurate, these types of updates are going to be more and more important because 5 hours out, weather apps could become less reliable. We take a look at all of the data that you may see on a weather app. All of this is produced from weather models. There's so many different weather models that every app is a little bit different. One app you have may take in just one model, one app may pull in a bunch of different data, but there's not really any kind of a human touch on these forecasts. And so if our weather model accuracy is going down, these apps are not going to be as accurate if there's no human intervention. It's why in every forecast that our meteorologists send out from BAM Weather and the Clarity platform, they have a hand in it. They have a hand in the hour-by-hour forecast. They have a hand in those nowcasts that we send out. And when all else fails, people that subscribe to Clarity Weather can chat with a meteorologist. A true one-on-one communication to break down specifics for your location, to help you understand the forecast, and instead of less certainty, have more certainty in what the weather is actually going to do. And so long story short here, weather model accuracy over the past month or two has gone down. It could be attributed to the loss in weather balloon data. Right here, you can see it. We've lost some of the data that has been happening from Alaska to the central part of the country, and a couple of other stations even suspended before 2025. And so getting a forecast from a real person is going to be so critical because meteorologists can see things that weather models can't. They can analyze them, determine which one is best, and give you a more reliable forecast. At the end of the day, we cannot take the human out of the weather forecast. All of these different AI systems that are promoting the most accurate and innovative weather data, it's great, but a human can still do better. And that's what we here at BAM Weather believe, and it's what we continue to focus on, especially given the changes ongoing right now in data reliability and the concerns there. Thank you all so much for watching. If you want to learn more about BAM Weather and Clarity, go to bamwx.com. We appreciate your support, and again, thanks for watching.